What is the relation?
A star minus k.
It is A star minus K. Okay, A star minus K. Here this Fourier series, remember this Fourier series coefficients are complex valued. So this is A star Bk is A star minus K. So how to get AK from Bk? Flip the signal. That means flip about the y-axis. This is a discrete sequence, isn't it? Sequence indexed by K. So flip that, take the conjugate, you will get the Fourier series coefficients of Bk. And if the signal is real, xt is equal to x star t. That implies that ak is a star minus k. And this is called the conjugate symmetry. Sorry, conjugate symmetry. In conjugate symmetry, what about this Fourier series coefficients are Fourier series coefficients ak are complex valued. So we can express this as ak is the magnitude of ak and the phase or the argument. We call it the phase. That is j, isn't it? Now tell me what is the relation between the magnitude and phase in the case of a real valued signal. For a real valued signal, ak is a star minus k. What about this a star minus k magnitude of that? Is it same as a minus k?
Yes, sir.
They're the same. And what about this? Is it minus? This is the argument. This is the notation we are using. Is this true? What I am writing here is if you consider a complex number, z is r e to the power j theta. And what is z r in complement means what is its conjugate in terms of the polar representation of its conjugate? Is it r e to the power minus j theta?
Yes.
That is what I am writing here. Okay. Now, if the signal is real, for a real signal, this relation we know a star minus k, that is the conjugate symmetry. Does it imply that a k is equal to a minus k in the case of real signal? If this condition is satisfied, oh sorry, is this sorry this one? What does it mean? This magnitude of that Fourier series coefficient, is it an even function of k? What is this? It is the magnitude of Fourier series coefficients. Is it an even function of k for a real valued signal?
Yes, sir.
And what about the phase? How are they related?
They differ by 180 degrees.
Is it this?
Yes, sir.
So can we say that this is an even function and this is an odd function of k? That is an important property of Fourier series coefficients. They are conjugate symmetric. For a real valued signal xt, they are conjugate symmetry. This is the conjugate symmetry. And if it is conjugate symmetric, the magnitude of the Fourier series coefficients are an even function of k, and the Fourier the phase is an odd function of k. Okay. So now let us discuss the next property. Next property is the this is okay. Did we discuss this property? xt Fourier series, Fourier series denote ak Then what about x minus t? Did we discuss this property in yesterday's class?
No, sir.
No. Okay. If xt is a periodic signal with period t naught, what about x minus t? Its reflected version. Is it also a periodic signal? Time reflection, does it change the periodicity of the signal?
It does not change.
If xt is a periodic signal, x minus t is also periodic signal with the same period, isn't it? If it is periodic with the same period, we can have a Fourier series representation. And if we denote the Fourier series coefficients by bk, then how these are related? This implies what? Xt is and this implies x of minus t is what? That is the meaning of Fourier means if we are given the Fourier series coefficients, we can express it as a linear combination of complex exponentials. Now tell me, what is the relation between ak and bk? If we put in this equation, will you get x minus t? Is it that? I'm putting t equals minus t here. Replace both sides with minus t, that function. Now we get this expression for x minus t, and this is another expression for x minus t. These two must be equal, isn't it? So can we write this as summation k minus infinity to infinity a minus k e raised to j k omega naught t?
Yes, sir.
Yes, sir.
Simply replacing k with minus k. Now we can directly compare these two, isn't it? These two are, left hand side is the same, x minus t, so this must be the same. Now tell me, what is the relation between ak and bk? Bk is what? If these two are, if we equate these two, how do we equate that? Series, infinite series. We equate the terms having similar, same, what? What is this term? This summation is it b0 plus, when k is 0, it is b0 plus b1 e raised to j omega naught t plus b2 e to the power j2 omega naught t. That is an infinite series. And here it is b minus 1 e raised to minus j omega naught t. And what about this? This is what? A minus, when k is equal to 0, it is a0 plus what? What is the value when k is 1?
A minus 1.
A minus 1 e to the power j omega naught t plus a minus 2 e to the power minus, it is plus j2 omega naught t plus, and here it will be a1 e to the power minus j omega naught t, isn't it? I'm expanding this series. Now, when we say that these two are same, does it mean that a0 is b0? Because that is the we have to equate the constant terms on both sides. This is the constant term, is it?
Yes.
A0 is b0. Let me write b0 is a0. What is b1? B1 is what? It is
A minus.
b1 is a minus 1. B minus 1 is
A1.
a1. So can we say that bk is equal to ak? A minus k?
Yes.
Is it? What does it mean? If xt Fourier series coefficients with respect to period t naught ak, x minus t is a minus k. Okay, with the same period, Fourier series with respect to the same period t naught. What does it mean? If you are flipping the signal, Fourier series coefficients are also flipped, isn't it? Is it?
Yes.
If you flip the signal, Fourier series coefficients are also flipped. Now let us consider an example. Okay, otherwise, let us first discuss this property. So if xt, I am saying the Fourier series coefficients with respect to t naught ak and x minus t is a minus k. Now what will happen if the signal is real? If xt is real, then what? What is the property of Fourier series coefficients? Xt, sorry, not xt is real, xt is even. If xt is an even function, that means xt is equal to x of minus t. This implies that what?
AK equals A minus.
If xt is even, what about ak? What is the meaning of this? Ak is equal to a minus k. If we flip the Fourier series coefficients, we are getting the same Fourier series coefficients, right? That means,
Yes,
is
sir.
it ak? The Fourier series coefficients are the Fourier series representation that ak is a what function? It is also an even function of k, isn't it? For example, if you consider cos pi t, what are the Fourier series coefficients? What are the Fourier series? What is the fundamental period of this? 2. With respect to 2, what are the Fourier series coefficients? The sine and cosine, you should remember this. I have explained it in the previous class.
Sir, half.
It is half, and for which values it is half?
K plus and minus 1.
Plus or minus 1, it is half, and all the other values, it is 0. So let me denote the simplified notation. This is, okay, then rest of the values are 0. Okay, only 2 non-zero values. This I am denoting by, that is the 0th value. Then 1 by 2, 1 by 2. This is an even signal, isn't it? Cos 2 pi t is an even signal. And if is this an even function of k? Is it a discrete sequence, even sequence?
Yes, sir.
Here, this notation I am using is, if you sketch a 0, this is 0, 1 by 2, 1 by 2, and all other values are 0. If we sketch it as a function of k, it is a sequence, discrete sequence, isn't it? Discrete, we can say that it is a discrete time. Okay, don't use the word discrete time, because so this is a this here case case discrete, isn't it? So if you sketch it, you'll get something like this. So sometimes I use this notation because this is the center, that a0, a1, a2 non-zero values. Okay, now what will happen if we flip this? This is an even function. Is it an even sequence? If we flip about the y-axis, you will get the same sequence, isn't it?
Yes, sir.
Now what about sine 2 pi t, sine pi t? If we take sine pi t, what are the Fourier? It's also Fourier series coefficients are means fundamental period is 2. So with respect to that period, you can have Fourier series coefficients. What are the Fourier series coefficients? Sine and cosine, you should always remember. Sine, it is 1 by 2, 1 by 2. There are two non-zero values, a minus 1 and a1. And for so sine, it is what? For cosine, it is 1 by 2. For sine, it is 1 by 2j and let's say minus 1 by 2j. Is it?
Yes, sir.
Okay. These two you should remember. It is very easy to find also. Now, what type of signal is this?
Odd.
This is an odd signal. Odd signal, if you flip, what about this? For odd signal, this is also odd. Fourier series coefficients.
Yes, sir.
So we can generalize that if the signal xt is even, ak is also even. If xt is odd, ak is also odd. Okay. Now what about this? If xt is real and even, if xt is real and even, what is the property of real valued signals? That is conjugate symmetric a star minus k. And for even signal, what is the property? If the signal is even, the Fourier series coefficients are also even. Is it this? So
Yes.
it will satisfy both these conditions. Okay. So does this imply that a star k is equal to a minus k? I'm taking conjugate on both sides. Is it that? Now what is a minus k? Since the signal is
K.
even, ak. So a star k is equal to ak. What does it mean? Fourier series coefficients are real value. Fourier series coefficients are okay. That is an important property. If the signal is real and even, Fourier series coefficients are real valued. And anyway, it is even also. So we can say that if xt is real and even, ak is what? Real and even. Isn't it? And in this example, cos 2 pi t, these are the Fourier series coefficients, only two non-zero coefficients, -1 and 1, at -1 and 1, and they are real valued, and this is an even function, isn't it? Even function of k. Is it? Now what about an odd signal? If the signal is real and odd, if xt is real and odd, for an odd signal, what is the property? Xt is equal to minus xt minus x minus t. That implies ak is equal to minus a minus k, isn't it? That is the property of for odd signal. That means if the signal is odd, this Fourier series coefficients, this is also an odd sequence. Now tell me what will happen if the signal is both real and odd. Real means what? ak is equal to a star minus k. It is conjugate symmetric. And odd means this one. So if the Fourier series this satisfies both the conditions, then using the same approach, we can prove that a star k is equal to a minus k, and since it is an odd function, ak is equal to minus of a minus k. So can we write a star k is equal to what?
Minus AK.
Minus ak. What does it mean? If you
Purely
take a,
imaginary.
sorry, this will happen only if ak are purely imaginary,
Yes.
isn't it? So that is the property. When xt is real and odd, ak is purely imaginary and odd. That means this example, cos 2 pi t. This is minus 1 by 2j. Real part is 0, isn't it? And it is an odd function. Okay. So these two are this is a very important property. You should remember this. If a real valued signal, if xt is real and even, the Fourier series coefficients are also real and even, and if it is real and odd, it is imaginary and odd function.